A block of mass m is released from the height h on the smooth ramp, which is frictionless. So which means that all the energy that this block have at this point, mgh, potential energy in the start, will convert into the kinetic energy at the bottom, and at this point it will have the maximum velocity, and that velocity will be maximum and it will stop after certain distance over this frictional surface, and this distance is d. So in this question you have to find out the coefficient of dynamic friction. So this question can be solved by two methods. The one method is the work energy principle, and the second method is Suvat, which I will write in the last of the video. As the block will be sliding on this frictional surface, the constant frictional force will be acting on it in the leftward direction, which will continuously stop it, decelerate it, and finally the velocity will be zero and the final kinetic energy will be zero. And what is the initial kinetic energy at this point? At this point, initial kinetic energy, if you want to find out, you should calculate first the velocity at this point. I'm writing it u because this is the initial velocity for this path, that's why. So let's apply law of conservation of energy to find first of all this velocity. Either you can say the sum of all energies at this point is equal to sum of all energies at this point, or you can say loss of potential energy is equals to gain of kinetic energy. So loss of ep is equals to gain, because no energy is lost, that's why. So we should say mgh is equals to, it is 100% converted into this kinetic energy. So from here we got the initial velocity for that rough surface, and this is going to become 2gh square root. So let's apply work energy principle. According to this, the work done on the rough surface, and the work done was only done by the frictional force because the other two forces, normal force and the weight, were balancing each other because of the horizontal surface. So work done by the friction is equals to the kinetic energy. So that is equals to the final kinetic energy minus initial kinetic energy. So as you see, work done is negative. Why? Because frictional force and the displacement covered have an angle 180 between them. Displacement is towards right, frictional force is towards left, whereas the final kinetic energy is 0 because body is stopping. So minus 1 over 2 mu square, and u square is, by the way, square of this term, that is 2gh. It is u square, not u. This 2 and 2 cancelled out, so it is mgh. Now you can put the value of frictional force, that is mu d, coefficient of dynamic friction, normal force into d is equals to negative mgh. Negative and negative is cancelled out. As you see, the normal force is equals to the weight, so you can say is equals to mgh. So from here the mu d is equals to h over d. That is the final answer. So h over d is the answer. Option D is the right answer. Okay, before you go, just quickly see this method. Pause the video and see this method. So as you see, first of all, this is a free body diagram from which this is a frictional force is a resultant force, and we got the this mu d equation, and then we applied the third equation of motion for this path, from where we have got the deceleration. Now you will put here, and then you will get the same result. So the same answer, option D. So whatever the method is seems comfortable to you, you can adopt that. Option is D.